Okay, Year 12, continuing with our work on vectors, and vector algebra is our focus for this screencast. And I want to introduce you to our friend, the unit vector. Unit vector. As his name suggests, he is 1 unit in length. But he's an important component of how we represent vectors algebraically. Okay, so what do we need to know? Not a lot, other than we've got a vector that goes horizontally and a horizontal vector that goes for 1 unit horizontally. I'll say that's 1 unit there. That is, okay, this is our vector going this way. And if it's 1 unit in length, then it's called I. He's given the title I, and the column vector is 1, 0. Now, if we're going to go in the vertical direction, then we will be talking about a vector that goes vertically by 1 unit, and we'll call him J, and he is 0, 1. If we go into the third dimension, into the then we'll pick up K, and that'll be 0, 0, 1. May as well talk about him now. I can't really describe him. These are in 2 dimensions, so the third dimension is popping off the screen, which is a little harder to perhaps represent. But if I was to try, then it would be something like this, and he would be K at 0, 0, 1. Okay, so if we were, this allows us to then refer to vectors in unit vector format. So we would talk about perhaps AB, which is I think it was a 4, 3 vector, just to stay consistent with how we were talking earlier in the last screencast. Then we could talk about that as 4 unit vectors in the horizontal direction plus 3 unit vectors in the vertical direction. So if you see such a thing, 4i plus 3j, it refers to the vector that goes 4 across and 3 up. If we were talking about CD, the vector CD, which went, I think 5, what did CD do? It was in the previous screencast. Well, in actual fact, to stay consistent, I better change AB to 5, 5, 3. So that's 5i plus 3j. And CD was in fact negative 7, 2, which we would write as negative 7i plus 2j. I'll get rid of this reference now. Good. Okay, we'll look at an example. Okay, turning to our attention to this example, we have 2 points here, A, negative 1, 2, and B, 3, 1. Write down the vectors OA and OB as column vectors. Okay, well, we understand column vectors, what they are. What's this O? Well, this O refers to the origin. So A and B are sort of position vectors. You can think of them as points, perhaps, in the plane. So A is, so this is our value. This is O here at the origin. So OA is 1 to the left and 2 up. So we would say that that is the point A there. And then B is 3, 1. So we'd go 1, 2, 3, and 1 up to find the position of B here. So B is over, A is here, and we could draw lines to those and the vectors. So 3, 1 is, so vector OB is going to look like this, right? That's OB there. And OA will be represented by the vector negative 1, 2. Okay, so there's OA and OB represented. Now find AB. AB is going to be, get my ruler out again, it's going to be the vector that heads across from A to B, like so. A to B, there it is. Okay, so we need to find out what AB is. Well, there's a few ways of doing this. We can write AB, the vector. Okay, so it's going to be B minus A, if you like. So it'll be OB minus OA. So that'll be 3, 1 minus -1, 2. So we'll get 4, -1. Let's just see if that looks about right. We're going 4 across and 1 down, so that looks good. The other way you can think of this, perhaps more intuitively, is to think, okay, I'm going from A to B, so I'm going from -1 to 3. So that journey from -1 to 3 is an increase of 4, and the journey from 2 to 1 is a journey of -1. So you can think of it in a more intuitive way like so, but that's going to be our vector AB. Okay, we're going to do this example. In fact, I'd like you to pause the video at this point and do this one yourselves. It's a 3D version of what we just did. So given these points in 3 dimensions, write down the vectors OA, OB as column vectors, and then we're going to write AB as a linear combination of the unit vectors. So that's using I, J, and K. So see if you can do that. Pause the video. I'll see you in a minute. Okay, let's compare notes. OA. So that's the position vector of A. It's a vector from O, the origin, out to A. So that is just going to be 1, 3, -1. OB is going to be 3, -1, 1. All right, that's part A, and part B is going to be AB is simply, how do we get from A to B? So think of the X movement from 1 to 3. Well, that's just 2. It's going up by 2. The Y movement from 3 to -1, so that's a drop in 4, -4. And then from -1 to 1 is going up by 2. So the AB vector, 2, -4, 2, but we're asked for it in in the linear combination of the unit vectors. The linear combination of the unit vectors. So the representation of that will be 2i ijk minus 4j plus 2k. Remembering that I, j, and k are the unit vectors in each of the x, y, and z directions. Okay, exercise 11C. Let's have a go at that.